So we're going to think about functions in a slightly different way, which is, you know how to think about a parabola in three different forms. What are they? Vertex form, standard form, and factor form. Today we're actually going to talk about vertex form, but we're not going to think about it as vertex form. We're going to think about it in a different kind of way. Does that make sense? And for a parabola, this is probably going to come really easily to you because you've worked with parabolas a lot, but we're going to try to use that as a stepping point to deal with other functions that you're not used to. All right? So if we have the most basic parabola, what's its equation? X squared. That's the most basic parabola, right? Because what makes something a parabola is that when you take the x value, you square it. Can you do other stuff to it? Add, subtract, multiply? Yeah, sure. But as long as the x is being squared, it's going to give you this parabolic behavior, right? In other words, it's going to do that loopy bit that parabolas do. So let's work with the most basic parabola, which is f of x equals x squared. What would negative 2 do for us? What y value would we get? What would the output be? What is f of negative 2? Yep. And what is that?
Negative 4.
Is that true?
Oh, wait, no, we have the bracket that's before.
Yeah, we won't write this for each one, but negative 2 squared is?
4.
What's f at negative 1? Well, it's negative 1 squared, which is? 1. What's f at 0? It's 0 squared, which is? 0. F at 1 is? 1 squared, which is 1. And f at 2 is 2 squared, which is 4. Okay. And we note we get that typical symmetrical behavior, right, of a parabola. And I've gone ahead and graphed that for you, right? There are the points. We all see it?
I wrote this.
Okay, now,
I had this.
what I want you to do is, we're going to look at this. What do I want you to do here? I want to make a new function, g at x. Do you see that? But g at x is going to be based on a previous function. You can do that. We're going to say to evaluate g at x, what I want you to do first is evaluate f at x, and then what do I want you to do?
Add 3.
Add 3. Do we see that?
Mm-hmm.
Is that allowed? Yeah. This is basing one function on another function, and we do it all the time. So let's do the same thing. And let's say negative 2 again. What would we get? Well, we would get what was f at negative 2? 4. And what are we being asked to do with that?
Plus 3.
Which gives us?
7.
All right, and remember, that's because we took this number and we put it there because we're evaluating f of x here, right? What will this be? Negative 1 would give us?
1 plus 3.
1 plus 3, which is?
4.
4, okay? And I'm going to keep highlighting where that number comes from because, again, what we're doing is to get g of x, we're using f of x. Right, so in each case, we're going to use that, which means that if we evaluated g at 0, we would get what? 0 plus 3, which is? 3. And if we evaluated g at 1, we'd get 1 plus 3, which is? 4. And if we evaluated g at 2, we'd get? 4 plus 3, which is? 7. Okay. Now, functionally, this is the same thing as if we had said, what? What's the other way we could write this? We could have said g of x is equal to what? What's the other version of this equation that doesn't refer back to f? X squared plus 3. Do we see how that's the exact same thing?
Yeah.
Right? Because what did f at x ask us to actually do? Well, it asked us to take x and square it. So instead of writing f at x, we could have just written x squared because that is what f at x does. Does that make sense? Let's put this on here. And what do we find? Where does this point live now? Negative 2 doesn't live at negative 4 or at positive 4. It lives at 7. And 1 doesn't live at 1. It lives at, or negative 1 doesn't live at, isn't it? Yeah, it is.
No, it goes.
Oh, it goes by halves. I'm sorry. Thank you. And I lied to you. I hate when Desmos, I didn't even notice that Desmos had done that to me when I made this. Stupid Desmos. Where does negative 1 end up lining up?
4.
At 4. And I'm going to get this one right. Well, I hope so. It's even on a line. Okay, and then where does 0 land?
3.
At 3. And then where does positive 1 land?
At 4.
At 4. And where does 2 land?
At 7.
Up at 7. Okay. And if we were to draw this parabola, it should look more or less, maybe less, like that. And what do you notice? Hopefully. They're the same shape. What's the difference between them? Yeah, the vertex moved up by 3, but really what happened to every single point? Every single point on it. If I tracked this point here, how much did it move up by? And this side looks a bit more symmetrical to me. I'm going to pick a totally random point here, just this point here, and say it moved up by how much?
3.
I'm going to have it land on a line because we know every 2 lines is 1, right? So 1, 2, and 3, and lo and behold, that's what it moved up by, right?
Yeah.
Up by 3. So the main thing to take away is every single point on the parabola has just been moved up by
3.
Has moved up by 3 to give g at x. So you could think of g at x like this and think of it as a parabola in vertex form. And the fact that there's no bracket here at all means that the x value of the vertex is
3. No, x squared.
There's no bracket there needed, right? Normally there'd be a bracket and the x value of the vertex would be in there, but it's not. So the vertex would be at 0. And the y value of the vertex is
3.
3. So you can think of this as a parabola in vertex form with a vertex at 0, 3, and a step pattern of 1. And that's totally accurate, right? Anything wrong with that? No. But the other thing you can think of this as is the base parabola, the default parabola, x squared, but moved up by 3. Does that make sense? Now, thinking of it those two ways gives you the same outcome, right? But one of them requires you to know how to draw a parabola starting anywhere. And the other one basically says, if you can draw the base parabola, you can now make this one, because all you have to do is draw the base parabola, but move it up by 3. For a parabola, does that make any difference to us? Not really. We know how to draw a parabola given the vertex, right? But for some other functions, this can be really useful. Does that make sense? Thinking of it, instead of having to work with that function on its own, but thinking of it as a modification of a simpler function can be really useful. Does that make sense? I see a lot of sleepy faces up here. Let's all stand up. Everyone stand up. Everyone stand up. Stand up. Stand up so long as you're everybody. You're everybody to me. Let's stand up. Angela. Stand up, dude. Stand up. No sleepy times. Listen, believe me, I get it. There's a reason I got the extra large coffee today, so I can get some sleep. I want you to go across the room to somebody you haven't talked to yet today and tell them your favorite thing to order at a fast food restaurant, whatever that might be. A fast food place could be a Starbucks, could be a Tim Hortons, could be an Arby's if you're smart. Whatever you want. And you got 30 seconds, so go sit back down. Favorite thing to order? What's your favorite thing to order?
Well, to start, I gotta decide what my favorite place to go to.
We got 12 seconds. Go.
Dairy Queen.
Yep.
And I like to get the boiled Reese's Blizzard from Dairy Queen.
That's a good choice. You, my non-participating friend, what's your favorite thing to order at some sort of quick service place? Could be anything. Could be a Slurpee at 7-Eleven. Could be a go. Sorry? That's fair. All right. Does anyone have an exciting thing they've learned about a friend they want to share? Yeah, go. There we go. I like it. Anyone else? Yeah. Are there really? Oh, there are, and it's like the 8 and they're cheap. Yeah.
So much better than McDonald's.
Are they?
So much better.
Interesting. Okay, go sit back down. All right.
That was fun.
Okay, so we can think of this as its own parabola, but we can also think of it as the basic parabola moved up. Does that make sense? And if you look at the instructions, it makes sense. Because remember, what we're saying is the output is the output of this one, but then what have we done to it? We've added 3 to the output. Have we changed the input? We've changed the output. And on a graph, what is the output portion of the graph? Which axis represents output? Y. So when we put a +3 on here, what does it change? The output. So it changes what values? The Y values. Does that make sense? This is changing the output, which means it's going to change all the Y values.
Wait, hold on. Can you scroll down to the second question? I just want to see something. Like,
Not yet. Give me a sec. So, as we do this today, I want you to always think about that. If something is being added to a function, it's not changing the x values because the function has already dealt with the x values. By the time the function has happened, we're dealing with what? Not the x values, but the y values. So this is going to change the y values. This is adding, but what else could I do to the y values? Could I subtract? Sure, instead of moving the graph up, subtracting would move the graph down. Could I multiply? Sure, you can multiply, right? If we multiplied, again, is that going to move the graph left and right, or is it going to move it up and down? Just up and down. Because again, this is saying the function has already happened. If I wanted to change it left and right, where would I have to make the change? Inside the function. I'd have to say, change the x value before you do the function. Does that make sense? And that's kind of why vertex form works the way it works. That why vertex form has to have those brackets, and it has to change the x before we square it. Because after we've squared it, it's already a parabola. We've already done the function. We've already changed the x's. Now, the only thing after that squaring, anything you change doesn't change the x's, it changes the y's. But if you make the change before you square it, since that is in fact the function, anything you change inside that bracket before you square it, that's going to change the, before you square it. Yeah, because now you're changing the input. And if you're changing the input, now you're changing the x values. Does that make sense? That's why the brackets in vertex form. Everything outside the brackets, the a value affects how tall it is. The value on the end affects how up and down it is. Those affect the output. The number in the bracket moves it left and right because that's not affecting the y value. It's affecting it before we've squared it, so it's affecting the input, which we call the x value. Does that make sense? And if you can learn to think that way and take some practice, it'll help you not memorize this as a set of rules, but actually be like, oh, I see why that tells me where the vertex is. Does that make sense? And that's a much stronger thing. If you understand where the vertex is because you understand how functions are being changed, as opposed to just memorizing a bunch of letters, that's an A, that's a K, that's an H, that's a much stronger thing. Does that seem fair? Okay, the other thing is, it doesn't have to be a parabola. What function is this? It's the square root of x, which you're right, looks kind of like half a parabola on its side. Well, because square rooting is the opposite of squaring, where instead of squaring to get the y values, here you actually square to get the x values. So it looks like a parabola on its side. So let's look at this. What's the square root of 0? F at 0 is the square root of 0, which is just 0. Okay? F at 1 is equal to the square root of 1, which equals approximately what? Can somebody do that in the calculator? This one's easy. This one's easy. What's it equal?
1.
1. Okay. But the next one isn't easy. What's F at 2?
I wrote it as 1.41.
Which equals approximately 1.41, right? Obviously, does it keep going?
Yeah.
It's an irrational number. It keeps going forever. But yeah. What's F at 3?
1.73.
Square root of 3, which is 1.73. And then, what did I mean to put here, obviously?
4.
4. Why did I put 2 again? Well, because what's F at 4? Is the square root of 4. And what's the square root of 4? 2. So I accidentally put the answer there. Sorry about that.
I already wrote it down. I'm going to just make another table. 4. And, yeah, that would be 2.
Okay. And then here, that was our function there. Why do I keep changing letters here? I am so sorry. This was supposed to be M and N, and then I obviously just went back to F and G. This is why we don't write lessons while we're also trying to... I don't even know what I was doing. But we'll just make that F and G so it fits. I left this blank because I want you to decide. Or does yours have it? Good, okay. Yeah. What do we want to do with this one? The last one we moved up by 3. What do we want to do here? Let's subtract. Do we have room for 3? Yeah, we got room for 3. 3 works, so let's subtract 3. I like that. We could also write that then as saying g at x is equal to f at x minus 3. Does that make sense? Because what's f at x? It's taking the square root of x.
It's supposed to be x minus 4 because it says move this function for you.
Oh, I
down.
did. Ah, there it is. So sorry, we would need to subtract what? 4. Thank you for reading. I'm glad one of us did. You'd think it'd be me because I'm the teacher, but here we are. Okay, so I want you to do this then and see what happens to that graph. Take a minute and do it. And if you think you got it, come draw it on here. I'm sure you'll do a lovely job. I have faith in you. You tell me? I want you to do it.
I already got it done.
Sounds like you're asking me a question, so I can do it. Sure, give it a minute, and then somebody go up and grab my tablet and draw it on them. I'm going to check in with these guys when I come back. I want that to be drawn on them.
Can I do it?
You want, but wait a minute.
PP music. Want to see this drawing I did?
I do. I love it. What's this drawing I did? Show me your drawing. Wow. Show me your drawing. You're mean.
That was there already. That was there already. If I'm gonna be honest, I did the same thing with the first owl. I literally just wrote, I have owl phobia.
My cat looks like an owl.
What the? WCat. I have 2 cats at home.
What's their names?
Thelma and Louise.
Thumma?
Yeah. Yeah, they're twins. My mom was the one that named them. I've never seen the show in my entire life.
No. Aiden. Jewish hand? Yeah. Like you, Aiden.
Do I? You know what? Fuck it.
Whoa, that was bad. Where's that?
Alright.
Bad word.
Flip it. Alright, guys, I'm the teacher for today. Let's see, so what we want to do is we want f of x minus 4. So g, I'm the greatest teacher of all time. So we g at x equals, let's see, f, oh, that's a w, look at that. That is a W looking F. So let me get rid of that. F at X minus 4. So we got our numbers. We got 0, 1, 2, 3, and 4. Is everyone following along now? Yeah, he said one of us get up and do it. He wants to see this done. So I'm doing it because no one else is. So what we need to do, if we have F at 0, that we all know that is obviously equal to 0. But we've got to subtract 4. And the answer, what is the answer, everyone? Can you see some hands?
-4.
Yes, good job. Better give you a raise. -4. That's a very clean looking -4 right there. When we have F at 1, we obviously got the square root of 1, which is equal to 1. So we write 1 here. Now what's 1 minus 4? That's supposed to be a 4. Hold on. Let me retry that. 1 minus 4. Yeah, I know he's on stream. Subscribe. We're trying to surpass Mr. Beast one day. Okay. So 1 minus 4. Can someone tell me what 1 minus 4 is? -3. Thank you. Should we work a little bit faster now?
Yeah, you don't need to write the whole thing.
All right. So let me so F at 2. We obviously know that is 1.41 minus 4.
All right, what we got? What happened to our function?
I don't know, but I'm teaching the class now.
Oh, let's do it.
I took over. All right, so we got F at 2. We obviously know that F at 2 is equal to 1.41. And here we need to subtract 4. So we got 1.41 minus 4. Can someone tell me what that is? I actually don't know. Let me look at my sheet. -2.59. Thank you. I know it's a little bit clumsy looking. So we got F at 3 now. F at 3, we know that the answer to that is 1.73. Now we got to subtract 4 from that. What do we get? -2.27. Good job. And now since I guess that was supposed to be 2, but it turned into a 4 magically because like some magician came by. Math and magician.
Can I? Never mind. I had a question. I was getting 1, but that's because my brain is addled by too much coffee. Carry on.
All right. So now we have F at 4 because now we have a 4, and we know that is equal to 2. So 2 minus 4, what does that equal? -2. Got it. All right. So now that we have all of our actual things, now obviously you could tell that some of these numbers are not very kind. Now we're gonna have to like kind of rearrange it. So I'm gonna go over this number a bit. I kind of wrote.
Okay. Don't worry about it. Just honestly change the colors. Go up and use green, and then just put big old dots.
Which one's green? That's not green.
Yep, that one.
Oh, it tells me. Thank you. All right. So we got -4 at 0. So we're gonna start over at the very bottom here at -4.
And remember, we don't graph to be exact. We graph to just do our best.
At F at 1, we go to -3, which is about here.
Beautiful.
Now, judging off of my sheet, because now these next two numbers are not very kind, so
Yeah, just do your best.
we have it right about here, I think.
Yeah, I agree. That looks great.
-2.27 at 3 would be like...
Kind of halfway, yeah. And then...
And this would be at -2. That's a much nicer number. And,
Awesome.
all right, hold on. Everyone wish me luck.
Oh, I know how you feel. That's pretty good.
See, no one wished me luck. See,
I
that's
wish
what
you
happens
luck.
when no one
That's
wishes
pretty
me
good.
luck.
That was great. Can we give a round of applause? That was like some good teaching. Well done.
I need my sheet.
Awesome.
I have the sheet back.
Yes, of course you may. There you go. That was great. Thank you. And what do we notice? Another way of thinking about this is that we could just take this whole curve and do what?
Move it down 4.
The whole curve moves down 4.
Oh yeah, by the way, you were streaming, so like everyone heard me.
You did great. Look at that. You're internet famous. If by famous you mean one person will ever watch that. But it exists, so there you go. Yeah, there you go. That was awesome. So now we can also move left and right. But to move left and right, we have to do something different. Because to move left and right, we obviously know the starting parabola here, right? Which is we can say f of x equals x squared. So we had 4, then 1, then 0, then 1, then 4, right? So we know that that's our parabola. But now let's take a look at this. Because what we're saying here is do g at x minus 4 and then square it. Does that make sense? Take x and do what with it? Subtract 4. And then do what? Square it. Does that make sense? Now, let's pause there for a minute. I want you to erase that. Let's just erase that for a minute. We're going to do that. So I shouldn't have said erase it, but that's okay. But we can write over top. This says x minus 4, right? Mm-hmm. But the problem is I want to use these numbers that I already have. So if I pick, don't do this. Don't write. Okay, everyone put your pencils down. Look at me. If I put negative 2 in here again and choose negative 2, what I'm going to say is g at negative 2 equals, and then what do I have to do with this? Well, I have to do negative 2 minus 4, and then I have to square it. And I could do that, right? But I'd get negative 6. Negative 6 squared is 36. Don't write this. Does that fit on my graph nicely?
No.
So I could do that, but I'm going to end up with a bunch of numbers that don't go on my graph nicely. But you know what I could do, actually? I could pick x values where I would actually be recycling here. I know, what am I doing with the x value every time before I square it? Subtracting 4, right? Okay. Well then, what if I want to reuse this number? I want to get 4 as the answer. Well, I know that what do I have to be squaring? Negative 2, right? The problem is, to get to that, what did I have to do? Well, I had to subtract 4 from something. So what number could I start with so that I will end up squaring negative 2 and getting 4? I could start with 2. Does that make sense? And then here, I need to end up getting negative 1 and squaring that to get 1. What number could I start with so that I would end up with negative 1, given that I have to take 4 away? 3 minus 4 is negative 1. And then here, I need to end up getting 0 and squaring that. What number could I start with so that I'd get 0 if I have to subtract 4?
20 million.
I could do 4, and 4 moins 4 est 0, et 0 squared, et 0. I'm assuming that's how they say squared. They say square, and then go, and they chew on their baguette, and they adjust their beret, and their neckerchief, their cravat. Anyway, if I wanted to get 1 and square it, to get 1, what number would I have to start with? 5, et 5 moins 4, 0. And finally, if I wanted to get 2 and square that to give me 4, what number would I actually have to start with? In other words, to get all the same numbers, and this is finally going to explain why our x's lie to us. In math, not in real life. Why do our x's lie to us? I don't know. But I know why they lie to us in math. In life, I'm assuming it's deep moral failures. But in math, it's because if what we're doing to the x's is subtracting 4, then if I want to get all the same numbers, all I have to do is make sure I start 4 higher than I did last time. Does that make sense? So last time I went negative 2, negative 1, 0, 1, and 2. Here, what did I have to start at? 2, 3, 4, 5, 6. So to get all the same y values, do
I have to write this down?
Oh, yeah. We did what? Well, we added 4 to each x value. And the reason, right, to get the same y values, what did we do? We added 4 to each x value. So we wanted to get 4, 1, 0, 1, 4. I wanted to get that same pattern. And I can do it. All I had to do to get the exact same outputs was change my x's. But this would make you think I need to change the x's by subtracting 4. But that would make the problem even worse. See, because we're going to subtract 4 from each x, to get the same answers, I have to start by doing what to each x?
Add 4.
Adding 4, right? This will give the same y values as the original function. And this is why we say our x's lie to us. Where if the expression says subtract 4 from each x, we can say, okay, well, I'll get a totally normal parabola if I add 4 to each x, because then that cancels itself out, right? And so I'll get the totally normal parabola, only it's not going to start with an x value of 0. It's going to start with an x value of 4, because I added 4 to each x value, right? So we do 2, 3, 4, 5, and 6, right? Does that make sense?
Mm-hmm.
And when we do that, what we find is that we get the same parabola, only it's moved to the right by how much? To the right by 4. Now this, and then I can even just work from step pattern, because what's the step pattern of a basic parabola? The first step is 1, then the next step is 3, and sure enough, has that moved over 4? Yeah. 1, 2, 3. And so there we go. And if you look, each point maps onto another point. That maps onto that point. That maps onto that point. This one maps onto that point. That one maps onto that. And that one maps onto that. You don't need to draw that necessarily because it looks chaotic. And I can erase it easily. You can't. But do we see that? How each point comes from the previous parabola? So the thing to understand is that this modification on the inside changes our x value, but it doesn't change it in the way we think it's going to. It's counterintuitive. Because if we're saying take each x value and subtract 4, then what we're going to do is we're going to get the same shape if we take all the x values and counteract that subtracting 4. And how do you counteract subtracting 4? Adding 4. Does that make sense? So if you add, if this says subtract 4, what you're going to get is a new parabola where all the x values aren't actually 4 less. All the x values are actually going to be 4 more. Because the point that would have been 0 before will now be at -4, right? So to get the -4 point from before, you'd have to go to -8. Everything's been moved over. So let's try that for, oh, I changed my mind and didn't change a thing. We're going to change this. Ready? Let's change these. I'm so ashamed. Does anyone know what this function is?
A very bad looking one.
This is f of x equals 1 over x. This is a function we don't really know how to work with very well, right? Do you know how to work with this very well? I don't.
Divide.
Yeah, I don't know how to work with this. That's okay. So this would be f of x equals 1 over x. So what would this first one be? F at -5 would be 1 over -5. And if you want it as a decimal, that's -0.2, right? And look, there it is. And what about this one? F at -1 would be -1 over 1, which is just -1. And sure enough, there it is. What about 0? F at 0 equals 1 divided by 0, which is, yeah, it's not even infinite. I mean, that's sort of what happens, but it's just not available. It's just undefined. You don't get a value. And so what we get is this asymptote. We get this place where there's no value possible. And then 1 over 1 would just be 1. And 1 over 5 would be 0.2 if we want it as a decimal. And there they are. So there we get this function. Now, if we want to move this equation to the left by 2 units, what do we have to do? Well, up here, we wanted to move it to the right by 4, right? We want to move it to the right by 4, right? So up here, we want to move it to the right by how much?
Left.
Or to the left, rather, by 2. So we're going to take that original x value, and we're going to do what with it?
Subtract 2.
And we're going to subtract 2. We're going to take the original x value and subtract 2, which means where is this one going to live now? -7. And this one? -3. This one? -2. This one? -1. And this one? 3. Okay. Now, what should all of these y values be? All of these outputs? Because g at x is going to equal 1 over x. And can I put -2 here? I have to put x plus 2, right? Because what I want to do is I want this to actually just be 1 over 5 again. I want this to be 1 over -5. But to do that, I have to do 1 over -7, and then what do I do with it? Add 2, and that'll make it -5. Does that make sense? And then what about this one? I want it to equal 1 over -1. So what do I have to actually put under here? 1 over -3 plus 2. Does that make sense? To get the same y value, we have to do the opposite of what we want the x value to do. If we want the x value to be 2 lower, then in the function, we have to not subtract 2 from the x value. We have to add 2 to it, right? Because then we're working with an x value 2 lower. So this would be 1 over -2 plus 2, which is the equivalent of 1 over 0, which is no value. This one would be 1 over -1 plus 2, which equals 1 over 1, which is 1. And this would be 1 over 3 plus 2, which is the same as 1 over 5, which equals 0.2, right? So the big thing to take away here is that when you go to change your function, if you want to move it left by 2, you don't actually subtract 2 from the x. If you want to get the x's to all move left by 2, in the math, you have to actually do what to them? Add 2. And I know that's counterintuitive, but that's because if we add 2, what it's going to do is it's going to make you get to that y value sooner. And by getting to that y value sooner, you're actually going to get to the y value more to the left, even though we added numbers here. That's why our x's lie to us. Now, if that's too heady and too weird to think about, then just what do we remember about our x's? They lie to us. And why do they do it? I don't know, because they're awful people and we hate them. No, we don't hate them. We don't want to hurt them. We want to hurt them like they hurt us. But that's fine. And now, what will that look like? Well, now this exact same point here won't happen at -5. It'll happen at -3. This won't happen at -1. It'll happen, or at -7 rather. This one won't happen at -1. It'll happen at -3.
Cafeteria menu, we have French onion soup for $2, Caesar salad for $4, egg salad for $2.50, assorted sandwiches for $3.50, and subs for $6. Our featured entree is meatball subs with fries for $6 and creamy chicken.
I agree, but
with focaccia bread for $5. That's all on today's cafeteria menu. Have yourselves a great day, Eagles.
Meatball subs are one of my favorite foods, bro. Like,
Me too. Did you just call me bro?
Yeah.
I liked it. It's good. The whole function moves left 2.
yeah, that's gonna be hard to draw. I'm not even gonna bother.
When we do
Oh,
f
you just
at
moved
x
everything
plus
to
2. So this explains why adding here actually subtracts the x values when we actually graph it. Because what we're saying is, hey, to get the y value, imagine the x value is too bigger than it is, right? But then actually put that at this x value. Does that make sense? Pretend it's too bigger, figure out the y, now put it here. So by adding 2 to the x value here, we actually move all the x's to be 2 smaller. Counterintuitive, but that's what happens when you're working inside a function. So in other words, when in doubt,
Desmos.
well, yes, when in doubt, Desmos, but also our x's lie to us. And the y's tell the truth. Okay, there's some homework there to work on with this. Make sure you do it. This stuff at this stage is pretty simple, but you got to get the simple stuff before we can get to tricky stuff. Does that make sense? So this should make good sense to you, but we have a danger. Look at me. We do this thing. Sometimes when the lesson seems easy, we go, do I need to do the homework? Or we do the first couple questions of the homework, we go, this seems easy, and then we stop. For sure, make sure you get to those late number questions. If you really think a lesson was easy, try doing the homework backwards. Start with the hardest one. Only if you thought the lesson was really easy. But if you ever did and you're like, I don't think I need to do my homework, start backwards. And if you can do the last question right off the hop and get it right, cool, you're probably right. But don't do the first question, go, that was easy, and then quit. That's a bad idea, because obviously these get trickier. Your quizzes are here if you want to grab them. Your homework is there. I hope you all have a wonderful weekend. I hope it's calming and relaxing and restful and peaceful. And what are other things
allowed to do that?
Fun.
Mr. Orlando, can you just move out of the way just a little bit? I just need to.
Really want you to grab her.
Yeah, sure. I have an extras here. Yeah, so overwhelmingly pretty well done. Some people still having trouble, but that's okay. That's what we're here working for. And I can't stress enough, if you are having trouble and you want some help, you know what you can come get? Help. You get help. Lily, dude, I got your quiz. Lily, do you have your backpack on with the bell going yet?
I do.
My feelings on that?
I'm so sorry.
Yeah, my feelings are negative. That's what they are.
As well.
I don't like it. You certainly might.
I was hoping I'd get in the halls before they get up there.
There you go.
I was hoping I'd be in the
I gotta run again because I got called into work.
All
Monday.
except waiting.
You gotta look at all the extra time you're getting.
Oh, because you were like excited about it. I didn't want to show your mind. No, I don't care. I don't care about your. Like, good for you. Oh, I just thought I'd upset you. Good job. I also said because I thought you. I also said because I wanted you to get over it.
I actually
Good job, dude. You think about that? I was so pleased for you. Let's man, there you go. What's that? What's that going to get? Oh, there you go. Here, go get your sandwich, my friend. What's that?
93. I deserve the sandwich.
Oh, I gave you yours. Right.
I got a 93. What's that?
Sorry?